This is another winner of a Tiny ML Award for innovation. Take it away, Jan.
All right, thanks so much, Adam. Hi, everyone. Yeah, as Adam said, our first product in the Eon category, the Eon compiler, just won a Tiny ML Award for Best Innovation. Today, I'm super excited to actually talk about the second product that is coming out in our Eon line. And kind of everything we try with Eon is to get machine learning models as small and as effective as possible, preferably even on brownfield devices, because I think that's where kind of the real power of TinyML is. Not so much in NeoSilicon, but places where you can actually deploy it on devices that you have already today. I'm not an ML engineer. I'm an embedded engineer, just found his way into machine learning. And I love signal processing. Because if I have really noisy data, which is very typical of data that I get from a normal sensor, like data that I have here, this is data coming from an accelerometer, a typical signal processing toolkit already has amazing capabilities of actually cleaning up this data and finding interesting features for me. So this noisy data, I apply a simple low-pass filter, and bam, I have a clean data set. This is the exact same data, just with a low-pass filter at 3 Hertz. Really amazing. And that means that if I, after that, want to learn from this data, I no longer have to have a very complex neural network that needs to kind of denoise this signal for me. I can just give this clean data stream to the neural network, leading to much smaller networks and those much more efficient algorithms. So the one thing that we like to kind of demonstrate with our community of I don't know, 10,000 developers at the moment at Edge Impulse is on-device intelligence is not new. It's been here for the last 40 years. We just call it signal processing. So we try to use signal processing always as kind of the first step in kind of solving any on-device intelligence problem. So that leads to much smaller networks, and we use kind of the neural networks to do this final layer of how do I actually distinguish between classes, or how do I predict the scalar value, etc. We try to pre-process as much as possible. So if you look at a typical ML pipeline, something that we would deploy, or one of the people in our community would deploy, this is always a combination of some form of manipulating the input signal, maybe downsampling, maybe windowing some of the data up. There's a feature extraction pipeline, signal processing pipeline, and then finally a machine learning algorithm, maybe a neural network, or some classical ML. I think everyone who's ever done any of the tiny speech or a keyword spotting example will have seen this. Input data, an MFC block or a spectrogram in the middle, and then finally a neural network to classify between the keywords. Now, what are the right parameters to choose here, right? Even in a neural network, you might not even know what you need. Do you need a convolutional neural network? Do you need 1D convolutional, 2D convolutional? How many layers? What is the learning rate, etc.? And given that that's such a prevalent problem in machine learning research, there's been a ton of optimization and work around doing kind of AutoML on the ML part. And that's really interesting. I mean, I love it when I can press a button and it will tell me actually, hey, your learning rate of 0.001 is not great. Try 0.005, it will actually work much better. But it can only do so much. And because for on-device ML, the full pipeline is much more interesting. This AutoML pipeline can only give me so much. It can, it's only as good as the input data. And given that there's so much work already done in the feature extraction pipeline, it's very limited use. So we figured, as at Impulse, what can we do about this and make this actually more useful? So we're going to be introducing our AutoML pipeline that can't just target neural networks, but will actually be able to cover this whole flow, all the way from what do I need to do with my inputs to what is the right feature extraction pipeline, and then what is the neural network or the machine learning configuration at the end. And that's called the Eon Tuner. This is how it looks like. Looks really cool. Eon Tuner will be able to evaluate a very large set of model variants with virtually unlimited parameters. We have a really nice Bayesian search protocol in place to drop models that we don't think are going to work. It can search over input parameters like the window size that you use, what frequency of data that you actually want to downsample your things to, over all your signal processing blocks. What is the right FFT length that I want to use here? How many peaks do I want to search for in my FFT? What is the right frame stride for a keyword spotting model or for an audio block, as well as over all our ML blocks. And the most brilliant thing here is that because this is totally built for TinyML, it does this within the constraints of your device. So the very first thing that you say when you start the EON Tuner is, what device do I want to run this on? What are my latency requirements? And what are my RAM and ROM requirements? And we'll use those constraints to actually start finding that best model. Edge Impulse is not a magic black button or a magic button where if you click to get an optimized model out, it's an engineering tool. So every single one of those blocks is completely extensible. So if you have a DSP block already today, you can plug that into the EON Tuner. You can specify which parameters should be evaluated. And then we're going to be able to run that pipeline completely over your code. And the same happens actually for machine learning blocks. For us, I think the really cool thing, we've been trying this out with the first customers, is a customer that's actually said that through the EON Tuner, they found that they didn't even need machine learning. They found the best DSP configuration actually for their data, and then they had a very simple decision tree written out by hand rather than having a complex neural network from that. So super excited for this. This will come out around April 2021. It will be available for everyone for free in the Edge Impulse Studio. So I can't wait to see everyone there and hopefully put a little bit more intelligence in your devices going into 2021.
Thank you very much, Jan. I think this you're trying to make it so tiny that maybe there'll be no ML, right? And then no.
In all fairness, would be great, right?
It's I agree. I completely agree. I don't think you should use ML if you could do it without, right? But I think it's a great idea to have an exploration toolbox. Could you comment a little bit on, let's say that you wanted to plug in, you mentioned you could plug in an extension. How would I go about plugging in an extension, a DSP extension I would like to evaluate? What would be the
So we have a standard SDK. It's already live. If you search for Edge Impulse custom processing block, you'll find it. So you can write it in any language. So in a higher level language, if you have something in Python already, that's fine. Or in MATLAB, also fine with people doing that, or in any other higher level language. You'll specify the parameters that we can have and what kind of the values are that we can plug in there. And then you offer that in the same way as you currently add a custom processing block in Edge Impulse. Just create Impulse, add a processing block, custom processing block, and then it will pop up. For enterprise customers, they'll have an extra option in their organization where you can just make this available for the rest of the org. So if you already have something, it's 5 minutes to plug it in.
Okay. And then we have a question from the audience about how much you rely on pre-trained models.
We don't rely on I don't believe in pre-trained models at all. I think model zoos are I don't think model zoos are, for example, the answer. Pre-trained models never solve never solve the problem that you actually have in your business. The only time you actually provide value if you have maybe a model architecture, that's great, or you have a recipe, or you have some signal processing parameters and a neural network architecture, but you always need to provide your own data, because otherwise, what's the value that you're actually bringing in? So we have a couple of transfer learning models for image data, etc. But the idea with Edge Impulse is always plugging your own data. Our very first step in our tutorials is always connect to dev boards and start collecting data. I think that's the only thing that really works here.
Okay, so I think from a TinyML point of view, I completely agree with you. But I'm assuming you could also probably use this tool for maybe bigger data loads. So in that case, maybe some pre-trained stuff could be useful, right? I mean, as a human being, we don't learn all the consonants every day, right? We learn we learn the language about it. So I'm assuming you support that too.
I do see the value in transfer learning models, right? And if you have an image model, I don't need my machine learning model to learn what contrast is or what basic shapes are, etc.
Yeah.
So yeah, absolutely. So things that we can do here now, for example, is we have a number of transfer learning models based on MobileNet v2 with a different alpha depending on the size of your model. And maybe actually choosing a model with a larger alpha but with a smaller input image works better than using a larger input image with a smaller transfer learning model. And those kind of questions you can answer really quickly with the tuner as well, because it will just iterate over all of those possibilities. You can plug in your own transfer learning models if you're a paid customer. So really easy to validate this kind of stuff.
Yeah. Okay, well, thank you very much, Jan.
Again, just a quick shout out to our sponsors. Bear with me for 1 minute. We have different categories. We have executive sponsors. First one being ARM. Then we have Qualcomm. We have Samsung. Platinum sponsors. Heda Compute. Lattice Semiconductor. Gold sponsors. BrainChip. Babel Labs. DSP Group. Edge Impulse. EMSA. Gray Matter Labs. Greenwaves. Himax. Imagimob. Latent AI. Maxim Integrated. Quixo. Reality AI. SensiML. Silicon Labs. Sentient. Google TensorFlow. XMOS. And lastly, silver sponsors, Edge Cortex, Hotchi, and Synsense.